Good day, stats students. So today we're going to go over section 9.2, part 1. And we're going to go over calculating a test statistic first and then a p-value. And the hardest thing about calculating a test statistic isn't actually probably the calculation. I can show you how to do that fairly easily. Thing that's the hardest thing is that you got to know your symbols. And so I've been preaching throughout the semester that you got to know your symbols, Well, it's time to do it. You got to know what x bar is, you got to know what mu is, you got to know what p hat, s, sigma, the whole thing. So if you don't, the whole thing kind of just blows up. And so please go back and memorize your symbols ASAP if you haven't. Trust me on that. So remember this formula. When I say remember this formula, I mean the formula on the left-hand side. And so this one right here. And so you got your z-score, it's observation minus mean divided by the standard deviation from chapter 2. We're still using that idea, okay? It's just that now we're going to substitute standard error for standard deviation. And so basically, that's the formula that we're going to use to calculate a test statistic. So it's basically the same thing that we've been using. So when calculating the test statistic, when testing the population proportion p, so obviously there's going to be a different formula for mu, but when testing the population proportion p, the test statistic will be that. And so we'll break down all the little parts here. Excuse me, in a moment. So, so the first thing I want to tell you is that the z test statistic for hypothesis testing is not equal to the critical value with confidence intervals. Do not substitute one for the other. They are two different concepts. The test statistic you have to calculate. The critical values, number of standard errors go out in both directions to create your confidence interval. They do not equal one another. Do not substitute one for the other. They are two different things. Keep straight, the test statistic is for hypothesis testing. Critical values are for confidence intervals. All right, that's the first thing. Second thing, p hat. So p hat is the sample proportion. We know about that. That's x over n. We've got to calculate for that for each problem. And is the sample size. So the only thing that's really left is this p sub 0, p sub 0, p sub 0. What is p sub 0? Okay, p sub 0 is simply the value in the null hypothesis. And so the reason why we're putting a little p sub 0 there and why the book does that is that, well, it's trying to remind you something. Where else have you seen sub 0? I think, well, at least I hope anyways, I think I have shown you that you've seen the null hypothesis h sub 0. And so what the book is trying to remind you that when you see sub 0, it means go to the null hypothesis, okay? And so I'll give you some examples here in a bit. Excuse me. So a researcher wants to test the proportion or the percentage, so it could say either one, of U.S. drivers that drive a foreign car. He randomly samples 100 U.S. drivers and 45 drives a foreign car. Tested 5% significance level, the proportion of all U.S. drivers that drive a foreign car is greater than 40%. Okay, so let's say that's our problem, all right? And let's say that we have to calculate our test statistic. And so p hat is x over n. So x is the number of successes. How many successes do we have? We have 45 people that drive a foreign car. That's what's being defined as a success here. And how many do we have? 45 out of a sample of 100. So there's n. And so we got 0.45 or 45% in the sample drives a foreign car, all right? And obviously is 100, we've already said that one. So, what is p sub 0 with regards to this? Remember, it's the value in the null hypothesis, all right? And so what we have to do is we have to actually formulate, well, what's in the null and alternative hypotheses. And so notice here it says test at the 5% significance level, the proportion of all U.S. drivers that drive a foreign car is greater than 40%. And so notice here, you could put 0.40 if you like to put the 0. I don't care. It doesn't matter if you drop the 0 or not, all right? But notice here, the alternative would be p is greater than 0.4, and what would be the null? P is equal to 0.4. So what's the value in the null hypothesis? What would be p sub 0? 0.4, that's it, okay? So we're not saying p is equal to p sub 0, we're saying p sub 0 is equal to 0.4. It's p sub 0 is equal to that value right there. Okay, and so p sub 0 is equal to 0.4 in this situation. So if you got to calculate your test stat, then you would put in 0.45 for p hat, 0.4, and notice you got to put 0.4 here, 0.4 here, okay? And that's slightly different than what you see in the confidence interval, because remember, p hat goes here and here, so be careful. P sub 0 goes here, p sub 0 goes there. Why are we doing that? Because we temporarily assume that the null hypothesis is true, okay? And we even use it to calculate the standard error. And that's the straight up answer, okay? All right, so hopefully you're able to put that into your calculator and get 1.02. Now, if you want to put it all in your calculator, all right, you can follow these instructions right here with your TI calculator. And I think it should give you exactly what you want. You got to just pay attention to when to put the parentheses. Otherwise, break it up into little pieces parts, okay? And so notice you got parentheses here, you got parentheses over here, and you got these parentheses over here. And that's probably the biggest problem, okay? And so if that's too much, if that's too many parentheses for you, break it down into pieces parts. And so calculate your standard error first, maybe, okay? And calculate your numerator, and there you go, okay? All right, so what does this mean? When we calculate the test stat, we come up with 1.02. What does it mean? Well, that means our sample proportion, our p hat, from our particular one random sample was what? 1.02 standard errors above. Why above? Because it's positive. If it was a negative sign here, it would be below, above the value of the null hypothesis. So that's how we go about interpreting this. All right. So there's your test stat. Hopefully you'll get a handle on that. You might have to practice a little bit. But how about p-values? That's something else that we have to look up at least, okay? So let's say that we had to calculate the p-value for the following, and we have p is equal to 0.2 and p is less than 0.2. So what I want you to pay attention to is that we have a less than sign here. That means we have a left-tailed test. And so this is what it means. And so I'm going to do my best to try to make a bell-shaped curve here, okay? And this is in terms of z, okay? And so, remember this would be 0, this would be -1, this would be -2, this would be -3, and so on and so forth, okay? So when you have a left-tailed test, what you got to do is you got to go to your, place your test stat on your graph here, which is a -2.51, which is down here someplace. We'll just put a line right here. And when it's left-tailed, what you do is you go figure out the area to the left of the test statistic, and that will be your probability value. That would be your p-value, okay? And so notice there is that this area right here that I just shaded is not a lot, right? And p-values, probabilities, that means it has to be between 0 and 1. And so note here that your p-value, okay, is going to be small, right? We didn't color in much of that. All right. So remember what the table is always giving us. Always giving us less than. So I think we can just look up a -2.51, and it'll be your p-value. So I have a table right here. So here's a -2.5. Here's 0.01. We see where that comes together, and there's your p-value for that particular problem. That's it. When it's left-tailed. Okay. When it's left-tailed. So we have the less than sign and the alternative hypothesis. Left-tailed. There you go. You just look up your test statistic. Okay. So again, a -2.51. All right, notice not too big, right? Okay, let's go to the next one. Again, left-tailed test. Left-tailed, right? Correct, I should have said. So I'm going to do again my best to, sometimes it's hard to do this on the laptop, and I didn't do a very good job that time, but I will have to do. Here's 0, right? Here's -1, here's -2, here's -3. -1.68 would maybe be about right here. Draw a line. This p-value looks a little bigger than the last one, okay? So we'll see. So -1.68, -1.6, here's 0.8, you see where that comes together, and that would be our p-value then, -1.68. So left-tailed, you get just look it up, okay? What about when it's right-tailed? And so when is it right-tailed? When your alternative is a greater than sign. So now we have a right-tailed test. Okay, what does that mean? We're going to go ahead and calculate the area to the right of the test statistic, and that will be our p-value. That wasn't too bad for our bell-shaped curve. So here's 0. This time we're going to go, since it's on the positive side, we'll go this way. 1, 2, 3. 1.02 is really close to there, right? So we'll go ahead and shade that in, okay? And so that area is representing the probability. Again, probabilities have to be between 0 and 1, okay? Can't be negative, can't be greater than 1. So let's take a look here. Now remember, the table's always going to give us less than, and so let's look up 1.02. Here's 1.0, here's 0.02. You see where it comes together. We got here 0.8461. But that can't be our answer, right? 0.8461 is what? 0.8461 is that area right there. And how do we calculate the p-value? We can take 1 minus 0.8461. And I'm doing my best to write this out. So it turns out to be what? 0.153. Oh, that's an ugly looking 3, but that's okay. 9. There's our p-value. Okay. Now, for those who know how to use the idea of symmetry, you can use the idea of symmetry here. That's fine. Okay. But there's our p-value. Okay. Notice that our p-value is between 0 and 1. Okay. Moving on. Here is another right-tailed test. Okay. Looks like our p-value is going to be small because when you have large test statistics, and a test statistic of 3 is pretty far away. Okay, so we can barely even represent this on the tables because we have 0, we have 1, we have 2, we have 3. Way down here is 3.04. So you're just going to have this tiny little itty bitty area over here. Okay, so remember the table's always giving us less than. So when we look up 3.04, here's 3.0, here's 0.04. We see where that comes together. We get 0.9988. And so 0.9988 is this stuff in here. So what do we got to do? We got to take 1 minus that. So 1 minus 0.9988, we get here what? 0.00012. Oh, that's ugly. That's okay. All right, 0.0012. There's our p-value. Okay. What about when we have a two-tailed test? Okay, two-tailed tests are. Remember, you are testing both less than and greater than at the same time. How do we know it's two-tailed? Because we have a not equal to sign here. And so what's happening here is that, let's say this is 0. Here's 1, here's 2, here's 3. 2.78 is way out here. So since we are testing both less than and greater than, what we got to do is we got to go find the area to the right of 2.78. We also have to find the area to less than a negative 2.78 because we are testing both sides, okay? And so we got to figure out that area too also. Now, I know it's hard to represent it here, but these areas should be exactly the same. And so you just got to look up one and and you're good to go. In my opinion, the easiest thing to do is actually look up the negative side first, but I'm going to show you, let's look up 2.78, okay? And we'll just go ahead and here's 0.08. So we got here 0.9973. Now be careful, this is where a lot of people go wrong. So that means this area over here is 1 minus 0.9973. That means this is 0.00207. That's supposed to be a 27, okay? Well, that means this area over here is 0.0027. So you got to combine these two areas together to get your p-value, okay? And so you can just multiply it by 2. You can go ahead and add them together, but our final answer would be 0.0054. Be careful. Take a look at that example and make sure that you understand, okay? One more, negative 1.34. Again, it's a two-tailed test, okay? And so here's 1, 2, 3. Negative 1.34 is maybe around here. So we got to go find that area, okay? And we also have to go find the exact same area over here. So I think if we just look up a negative 1.34, let's go ahead and look that up, negative 1.34. And remember, less than, we don't have to do anything special with it, 0.0901. So that's 0.0901. That means that's 0.0901 over there. That means our p-value is 0.1802.